Hi all, Design Specialist Adam here, and welcome to another Jacobs Hall video tutorial. Today we'll be going over submission guidelines for parts produced on our Shopbot, a 3-axis CNC router used for 2 and 2.5 dimensional subtractive machining operations in woods, plastics, and foam. This video does not cover the full range of tool pathing options available to you in CAM, nor does it cover machine operation training. Both of those topics will be addressed in other videos. What we will talk about includes the machine's capabilities, the materials we currently stock, and materials we're willing to cut, some DFM considerations for your part, setting up your CAM files, and procedure for submitting your files through JPS. The Shopbot PRS Alpha 9648 has a build envelope of 96 inches by 48 inches by 6 inches, meaning any part that exceeds those dimensions must be broken into several parts that can be assembled separately. The 6-inch height constraint is additionally a little more complex than it initially seems and could more accurately be described as a combination of values that include the end mill length required to machine your deepest pockets and the maximum height of your part that must be preserved. A 6-inch maximum, for example, assumes that your part can be machined using one of our shortest end mills. If you have a dramatic 5-inch pocket, say, and need to use a long tool to machine the full depth, the tool must be able to retract 5+ inches to clear the part on its way to another operation. If you aren't sure whether or not your part's geometry is possible to achieve using the Shopbot, schedule time with a design specialist on our website. When in doubt, and if you are able, give yourself some clearance on the height, width, and length of your stock so you don't need to fight with any of the machine's hard limit switches during fabrication. Our Shopbot is capable of machining most materials softer than aluminum, primarily wood, including plywood, machinable plastics, and foams. If you're looking to make a part out of metal, check out our JPS submission process for the Tormach, or consider a flat or bendable part made on the FabLite laser cutter. The Shopbot spindle speed runs up to 18,000 RPM, and the top cutting speed is 600 IPM, inches per minute. Although for most woods, we run it slower, between 100 and 200 inches per minute. We currently stock 2 thicknesses of unfinished plywood, and you can buy quarter, half, and full sheets of nominally 3/4 inch and nominally 1/2 inch ply. These materials are good for flat pack furniture, large rigid structures, and laying up multiple sheets to make 2.5 dimensional shapes, i.e. shapes with no undercuts. We also stock 2 foot by 4 foot by 2 inch sheets of XPS foam, which can be good for looks like mock-ups and scale models. At the moment, the only plastics we have in stock that are especially good for machining come from our other mill catalog and are limited to 4 inches by 5 inches by 1/4 inch, but we're willing to accept and machine most plastics that can be safely and successfully milled. Let's jump into Fusion and talk a little about some design for manufacturability considerations for CNC'd parts. We do process our CAM toolpaths using Fusion 360, so if you're designing in SolidWorks or Rhino, please export your part as a step file loaded into Fusion 360, which is free with an educational license, and prepare your CAM files as follows in this tutorial. First and most obviously, your part needs to be possible to machine from either a single direction, or you need to provide a workflow for flipping the part. If you're new to CAM, we definitely recommend you stick to machining your part from a single side, although machining 2 or more sided parts is technically possible. Consider also how you plan to hold down your part. For work holding, we use screws, brackets, and sometimes double-sided tape in cases where our cuts are very light or low to the spoil board. Make sure you consider how your part will be held down and avoid trying to machine a part from stock that is too close to the size of the part to be adequately secured. End mills. Our end mills range in size from 1/2 inch to 1/8 of an inch and use either a flat or a ball profile. Flat is good for clearing out material and cutting around the edges of your part. Ball is better for detailed work and cleaning up curved faces, but isn't able to create right angles inside corner pockets. We also stock upcut, downcut, and compression end mills, which are each good for limiting tear out on the top or bottom of your part depending on the cut. We usually choose these for you, but if you have a preference, you're free to note it in your README file. We won't talk much about CAD in this video, but you want to be sure that your part is machinable and as organized as possible before sharing it with our design specialist staff. Before exporting, try to hide irrelevant components and only feature the part you wish to machine in the orientation you wish to machine it in. Before exporting, however, please set up your CAM to the best of your ability. We will, in some cases, agree to help you generate the CAM file from your CAD design, but we would rather do this during a scheduled meeting than try to make assumptions about the kind of resolution and tools you'd like to use for your part. To get started in CAM, drop into the CAM workspace. If this is your first time setting up a part for JPS submission, you'll need to import our tool libraries. Go to this address to download our libraries, and then import them into Fusion using the process illustrated here. Create a setup for your part. In your setup, specify the orientation of your part by selecting the following work coordinate system and choosing the proper axes. On the Shopbot, the longest dimension is the y-axis. The dimension perpendicular to that is the x-axis, and the vertical dimension is the z-axis. If you're buying materials from the Jacobs store, set up your stock dimensions as fixed and include the actual thickness of the material you're buying for. For length and width, you can just give us your part size plus 1.5 inches on those two sides. If you're supplying your own material, give us the exact full dimensions of the stock and position your part within it using the included controls. Go back to the first tab and set your stock box point. It's common to reference your Z off of a corner closest to the spoil board if you intend to face your stock to a specific thickness, or if you have multiple operations that will change the height of the top surface. We also tend to reference off of the corner closest to the Shopbot computer by convention, unless you have a good reason to do otherwise. Select a tool for your first operation. This will often be an adaptive clearing pass that uses the largest possible flat end mill, 1/2 inch, and select the maximum depth of cut appropriate for your material. Continue to add operations as appropriate. A typical part may include a few adaptive clearing passes with progressively smaller end mills, and then if there are contours or curves, a few passes with ball end mills, and finally a cutout 2D contour pass with a large flat end mill around the edge of your part. For more information on CAM, check out our written CAM guide here. Once you're done with your setup, simulate it to make sure you're not seeing any collisions and that the final results of the simulation look as you intend. Once you've simulated your CAM and are happy with your results, export your F3D file by going to File, Export, and selecting F3D to your desktop. If your part includes subassemblies that are linked to other files, Fusion will ask you to save it as an F3Z for zip file. We prefer that you take the time to break any links that exist and save as a simple F3D file. You'll also submit a readme.txt file that includes relevant information about your part. The more information, the better, including the expected use of the part, work holding preferences, desired resolution of finish, and the overall expected dimensions, including units. If you have any other drawings that would be helpful or photos, please include those as well. All of this information can be submitted through our JPS portal found at jps.jacobshall.org. As always, if you have any questions, please email jacobsprojectsupport@berkeley.edu or schedule an appointment with a design specialist.